Good morning, students. Once again, I welcome you to my video lectures on signals and systems, chapter 3, according to me, that is Z transforms. In this class, I will give first, once again, in the form of introduction, I will highlight the advantages of Z transforms. Why should we transform time from time domain to frequency domain? So, go through this paragraph. In this chapter, we study the Z transform used in linear system analysis and design. Analysis. What do you mean by analysis? Analysis means the system will be existing. We make a thorough investigation into the behavior of the system. That is called as analysis. Analysis. What do you mean by design? Design means to build a system to satisfy our requirements. First we state requirements, and to fulfill our requirements we build a system, that is called as design procedure. So in the analysis procedure as well as in design procedures we come across Z transforms. The Z transform offers significant advantages relative to time domain procedures. So when you go through, you will appreciate. When possible, we model discrete time physical systems. For example, I have taken an example, the example of digital filter. When possible, we model discrete time physical systems with linear difference equations with constant coefficients. Always we start with difference equations. For discrete systems we have difference equations. So taking difference equations we have to transform into Z time. That is, even difference equation is also a time domain equation. So it is to be transformed to frequency domain with constant coefficients. This Z transform of a difference equation gives us a good description of the characteristics of the equation. That is called as model. We call it as model, and hence of the physical system. In addition, transformed difference equations are algebraic, therefore easier to manipulate. In particular, the transformed equations are easier to solve. I will give an example. In addition, transformed difference equations are algebraic and therefore easier to manipulate. This is one point. And another point is, are algebraic and easier to manipulate. In the case of Laplace transform, you recall, in the case of Laplace transform, in S domain, impedance can be added. For example, Z1 of S can be added with Z2 of S. Impedance can be added because algebraic. But is it possible to add with inductive reactance with R? You can't directly add resistance with inductive reactance. Whereas in S domain, if you take Laplace transform for XL and a Laplace transform for R, then you can add. For example, what is Laplace transform for R? Same. Laplace transform of a constant. Then what about XL? XL is, we know that XL is equal to 2 pi FL. Then XL of S is equal to S omega L. J omega L. See, SXL, and you can directly add. Algebraic, when you have algebraic entities, you can add. But in time domain, they are phasors. You can't directly add. That is the advantage. So in this go through this paragraph, which will highlight the advantages of Z transforms. And in the next class, I will start with Laplace transform, because Z transform is extension of Laplace transform. And from Laplace transform, one has to derive Z transform. Thank you.